In this video, we will look at how we can use function graphs to evaluate composite functions. So I have the graphs of two functions f and g shown here. So we've got f on the left-hand side and g on the right-hand side. What we're going to do is start by evaluating this expression right here, f of g of 6. So this expression looks a little scary at first, but when we break it down, it's not too bad. So we start with 6, we'll start in the inside. We start with the value of 6, which we're using as the input to the function g. Then g of 6 is the output of g when the input is 6. We're using that output of g as the input to the function f, and the whole expression then represents an output from the function f. So we'll start with the inside, we'll look at that 6. We want 6 to be the input to the function g, so we'll look over at the graph of this function g. If we zoom in a little bit, we can look up to the graph, we've got a point there, and the corresponding output for g is 2. So we could say that g of 6 is equal to 2. So looking back at our original expression, f of g of 6 is really just equal to f of 2 because g of 6 is equal to 2. So now we're just evaluating f of 2, which we know how to do using function graphs. We look at an input of 2 for this function f, we look up to the graph of f, and we see that the corresponding output value is 1. That is, f of 2 is equal to 1. Therefore, in our original expression, f of 2 is equal to 1, and so f of g of 6 is just equal to 1. We just have to go through two function processes to determine this new output value. Okay, let's erase some of our scratch work here and evaluate another expression. So this time, let's look at the expression g of f of 3. So again, it looks a little scary at first, but we can break it down into pieces. We start with an input of 3, and 3 is being inputted into the function f. Then we're using the output of f as the input to the function g, and we want to know that output of g. So we'll start with f of 3. So we're looking at an input of 3 into this function f. We look up to the graph. See we have the point there. The corresponding output value is 6, and therefore f of 3 is equal to 6. And hence, g of f of 3 is really equal to g of 6. So we know how to evaluate g of 6. We look at an input of 6 for this function g. We look up to the graph. See we have a corresponding output value of 2. So when the input of g is 6, the output is 2, and therefore g of 6 is equal to 2. And therefore the value of this whole expression right here is just equal to 2.